Hello students, in the last video I talked about bearings. I introduced you to bearings, true bearing, quadrant bearing, and we did quite a few problems. But I was cut off in the end because of the time limit and I was just starting on a word problem. So let me start where I was stopped. So this is the bearing word problems and it's good in a way because this will have more time. So let's look at bearing word problems here. A Boeing aircraft takes off from Austin Airport, which has a bearing of 922 degrees east. So whenever you see a bearing problem, immediately just draw this north and south directions and so on. And here he's saying 20 degrees east, right? 20 degrees east. So 20, this is 20 degrees to the east. It's bearing to the east direction. So the aircraft, he takes permission to turn 90 degrees. So from here, he actually turns 90 degrees. And he actually flies 1 mile from here. And from here, 90 degrees. And he goes 1 mile, and here he travels 2 miles in this direction. That's what he says. So from here to the origin, my proportions are not really fine. Okay, it gave me another chance. Okay, so this is 2 miles. This is 1 mile and this is 2 miles. So the idea is he's saying what bearing should control tower use to locate the aircraft? So which means I have to find this angle from here to here, just this part. Okay, we know that this is 20 degrees, okay, and we need to find this, meaning it's much easier for us to find the whole angle from here to here in the triangle and subtract 20 from there. So how would we find that angle? So now you have to use the knowledge of our trig ratios. We have the opposite end. Let me write this clear. This is 2 miles. I'm just erasing it. So we can, yeah, perfect. So this is 2 miles. This is 2 miles. So, and this is 1 mile. So we have here opposite side of this angle that we need to find and the adjacent side 1. So which trig ratio you would use that involves opposite and adjacent? Yes, you're right. It is tan. So theta is the angle that we need to find and opposite end is 2, adjacent is 1. So what is the angle? Theta. So theta is inverse of inverse of 2. Okay. Now you would just take your calculator and switch it on, of course. And now we have tan inverse or inverse second inverse of 2, close the brackets, equals 63.4 degrees. So we got it as 63.4. But remember, part of it is 20 degrees. We need to find the other part. So we just have to subtract 20 from here, which is 43.4. So how would you write it? In quadrant bearing, you would write it as, this is in the west direction, it's bearing toward the west, right? So it's north bearing toward west, 43.4 degrees, and that's how you write it. North, 43.4 degrees bearing toward the west. Or if you want the true angle, true bearing, you would find this whole thing in the clockwise direction. So in the clockwise direction, this will come to 360 minus that, which is 316.6 true. Okay, that's how you do this word problem. All right, and this is, sorry, wrong window. This is the kind of typical problem that you would see. And now we would go to the second kind and let's read through the problem. So Jack and Jill start walking toward each other. Oh, there are 2 points now. Jack and Jill, they're starting to walk toward each other. So let's draw that as Okay, so this is Jack and this is Jill. Okay. So he's saying they're 40 feet apart. At a distance of 40 feet apart, they spot a butterfly through the flowers on a bearing of 932 degrees east from Jack. So that's our reference. We need to see from where he's talking about. For Jack, the butterfly is at 32 degrees east. So let's draw a dotted line just so we don't get confused with so many lines. Okay, this is the north for him, and he's saying he spotted a butterfly somewhere here, which is okay, somewhere there. 32 degrees. So this angle is 32 degrees toward the east direction, and on a bearing of 950 degrees west from Jill. So the same butterfly. So that's why we are connecting to the same butterfly here. Okay, so that is okay. Let's first draw the dotted lines here too. This is the north for Jill, and he's saying 50 degrees west. So this angle is 50 degrees. Okay, so he's asking how far is the butterfly from Jill? So this is what we need to find. This is the butterfly. Okay. So how far is Jill from the butterfly? So we'll call it as x. So now let's try to solve the problem. What kind of situation is this? The known situation. So we normally see, we can definitely find these angles in the triangle. Okay, just 90 minus 32 for this, which is 58. And this would be 90 minus 50, so this angle is 40 degrees, right? So 14, so which means we can easily find this guy, right? This is then 180 minus sum of these two angles, which happens to be 82 degrees. Okay. All right, and the opposite side distance, we know that's a known thing. If they are 40 feet apart at that particular point where they spotted the butterfly. So now we have the angles ready, the measures are ready. This is the unknown measure that we need to find. So it's best to use law of sines. So we would use sine 82 divided by 40 equals, so since x is opposite of 58, we are going to take that, sine 58 over x. Okay, so we'll do the solving part. I want you to figure it out, but it'll come back to this. You can pause and play, work it out and come back. You will see that this would be 40 sine 58 over sine 82. Okay, so you can use a calculator. Let's use it quickly. Okay, this is much more compact. So 40, we should switch it on, 40 sine 58 close divided by sine 82. Close it. And you'll get 34.255. We'll round it off to the tens. It'll be 34.3. How many is it? Feet. So this is feet. 34. That's the answer. Okay. So I believe the next problem, John and Katie problem, is also a similar one. So I don't want to solve that for you. I want you to try it. The key will be online in Schoology. Okay. I hope this helps. I'm talking about this. You can try this out by yourself. So I hope this helps. Please come to my next video. Thank you. Thank you so much for watching.